Hi friends, today I am going to explain the Coulomb's law from electrostatics 1. So in this chapter we are going to study about the static charges, when the charges are in rest condition. Okay, so first we are going to start with the Coulomb's law. First, initially I have two charges. We have a charge q1 here, we have a charge q2 here. So the separated by a distance r. So by r is nothing but xi plus yj plus zk. Okay, it's a distance between two charges. So if I have my two positive charges, it's going to be a ripple. If I have a two negative charges, it's also is going to be a ripple. And then if I have a one positive charge and one negative charge, it's going to be attract each other. In this case, I am considering both the charges are positive to explain my Coulomb's law. First, there is a repulsion force, or actually I am going to write only the magnitude of the force. So the force between these two charges, I may write my force between my q1 q2 F is directly proportional to the product of the charge q1 and product of the charge q1 and q2, and inversely proportional to the square of the distance between them. So my force between both the charges is increased by when the magnitude of the charge gets increases, my force between these two charges gets increases, and the separation between the charges gets increases. The magnitude of the force will reduce. So now I am going to replace this proportionality symbol by a constant. It's called k. So my F equals to some k times q1 q2 by r square. What is this k? This k is a proportionality constant. So a proportionality constant is always tells about the nature and dimension of the system. In this case, this k it tells about what kind of medium between these two charges. This tells about what is the dimensions. So a proportionality constant is always tells about the nature and dimension of the system. So this is my equation 1. So first I am going to explain this k part. This k equals to 1 by 4 pi epsilon naught. So this epsilon naught is nothing called, this called your permittivity of the air or vacuum. So epsilon naught equals to is nothing but permittivity of air. Sir, what is the importance, what is the significance of this permittivity? So listen carefully. You have a charge 1, I have a charge 2. So now there is a force between these two charges is said to be a constant. Okay, so we have two charges separated by distance r. So now there is a force between these two charges. In case if I place a material and any other material, if I say I am supposed to place this box between these two charges, the force will affect or not. Obviously, if I place some other medium in between these, in case if I am placing my hand here, what's happening? My force will get affected. So my force is not only depending upon q1 and q2 and r square r, it's also depending upon what kind of medium between the two charges. So this epsilon tells about the nature of the medium, which is called in this case I am considering this is nothing but my air. There is a air between the two charges. So the strength of the medium gets increases, my force gets decreases. If I place my hand between these two charges, what's happening? My magnitude of force between these two charges gets reduced. So my permittivity of the air is a constant. If I place the same charge into some other medium, my permittivity will change. I will explain the next section here. So my permittivity of the air is the constant value epsilon naught equals to 8.854 into 10 power minus 12. Okay, is going to be a constant value. Then how can I write the SI unit? So I am going to substitute this k value here. My F will become F is equal to 1 by 4 pi epsilon naught q1 q2 by r square. Okay, so now I just want to write the S unit of the epsilon naught. So if I bring this epsilon naught in the numerator here and force here, force in the denominator, and then first I am going to write Newton inverse, and then we have a S unit of charge is going to be Coulomb, Q1 and Q2, and continue to write Coulomb square divided by R square is nothing but meter inverse square. So this is the SI unit of the permittivity of the air or vacuum. In this case I am considering this is air between the Q1 and Q2. Sir, what about my 4 pi? So I previously told you a proportionality constant is always tells about the nature and dimension of the system. So my epsilon naught tells about the nature of the medium between these two charges. What about this 4 pi? So to explain about this 4 pi, I am going to give you an example. Consider a football, because I need a spherical shape. So for that I am going to explain you using a football. Considering a football, so I am going to consider a football of radius r. So r. Okay. So first I am going to place my charge Q1 here and charge Q2 here. So my charge Q1 in the center of the football, my charge Q2 on the surface of the football. If I move my charge Q2 anywhere on the surface of the football, if I move anywhere on the surface of the football, my force won't change, since my R won't change. When my force will change? When my R will change, then only my force will get affected, because my R only decides the force between these two, because my magnitude of Q1 and Q2 are fixed. So my R only decides the magnitude of the force between these two charges. So when my force will vary, then the total surface area of the sphere varies, then only my force will varies. What is the total surface area formula for a sphere? 4 pi r square. Sir, why you are considering a sphere? See, if I have my positive charge here, if I have my positive charge here or negative charge here, what's happening? My electric field not only moving from here to here, my electric field is going all directions, all 360 directions. If I suppose to consider a negative charge here, my electric field lines coming from all directions to this is going till infinity, or another negative charge, it is coming from infinity or from another positive charge. So if I am taking a spherical sphere, I am considering the entire field lines. Okay, so that's why I consider a football. So if you're sitting in the center of the football, okay, if you're placing a charge Q1 in the middle of the football, if you are placing my charge Q on the surface of the football, if you are move your football charge on the surface of the football, there is no change in my force. When your total surface area of the football gets increases, then only your force will affect. So already we have a r square here. I am just using this 4 pi. So this is my Coulomb's law. So this term tells about the nature and dimension of the system. This term tells about the magnitude of the charge, and this term tells about the separation between the two charges. Sir, what's happening when I place this charge into a particular medium? Say for example, I have a Q1 and Q2 separation by some distance of 1 meter, for example. So yeah, before going to the medium, I will explain what is meant by 1 coulomb. So I can simply take here. So to define what is meant by 1 coulomb. So if I say this charge is 1 coulomb, if I say this charge is 1 coulomb, how can we define? So first I am going to explain here. So this is my F here. I can simply write. So my Q1 equals to Q2 equals to 1 coulomb. If I am considering two charges are equal magnitude, in this case I am considering as a 1 coulomb Q2. The separation between them is to be R equal to 1. If I separate two charges in 1 meter apart. Now what's happening? This is 1, this is 1, this is also 1. So this term is gone. So my F equals to 1 by 4 pi epsilon naught. So if I substitute this 4 pi value and epsilon naught value here, I am getting my force value is in the order of 9 into 10 power 9 Newton. This is very important result. When two charges separated by a distance of 1 meter apart, the force experienced by the either of the charge is said to be 9 into 10 power 9. Then that charge is said to be, the magnitude of charge is said to be 1 coulomb. So this is the definition of 1 coulomb. So if you have doubts, you just text in comments. I'll explain in the next class. Okay. So next, sir, what's happening if I place this charge configuration inside a medium? I'll explain now. So I just retain this information here. So I'm going to erase this part. Okay. So this is in the presence of air. Next I'm going to place these Q1 and Q2 without changing its distance into a particular medium. Say for example, in my case it's going to be inside the water or inside the honey or inside any medium. I don't know what's that medium strength. So I can take this into some other medium. So this comparison is very important when you are solving for competitive problems or board problems. It's very important. So in the presence of medium, so this actually this is my equation 2. Medium there is no change in my Q1 and Q2 and R. Everything is same. So I can simply take it as this is going to be F prime. There is no change in my charge, there is no change in my distance, but there is a change of your medium. So this is going to be F prime 1 by 4 pi epsilon naught. Instead of epsilon naught I should use epsilon. Okay, instead of using epsilon I should use epsilon. So here Q1 Q2 by R square. So what is this epsilon? So epsilon is equal to your permittivity of the medium. See, for a particular medium we have a constant permittivity. For a different medium we have a different permittivity. So this varies with respect to medium to medium. So this is my equation 2 and this is my equation 3. Okay, right? So what I am going to do here, I am going to compare how that medium permit your electric field lines. So permittivity, the technical term because of the how much of medium permit the electric field lines through it. Okay. So I'm going to compare my permittivity of the medium with respect to air. So because I know my air value is going to be a constant. With respect to air, the medium will permit more, the medium will permit less. I am going to compare between these two. For that I am going to do here. So I am going to divide my equation 2 divided by equation 3 equals to F by F prime. This is equals to 1 by 4 pi epsilon naught Q1 Q2 by R square divided by 1 by 4 pi epsilon Q1 Q2 by R square, right? So this term and this term gets cancelled and 1 by 4 pi 1 by 4 pi gets cancelled. This will become F by F prime equals to epsilon by epsilon naught. So this is nothing but the permittivity of the medium divided by permittivity of the vacuum or permittivity of the air. So I'm going to write a new technical terms called your relative permittivity is equal to epsilon r. This epsilon r is called the relative permittivity of the medium. Relative permittivity of the medium. Sometimes this relative permittivity is called capital K. It's called your dielectric constant. I will explain this part in the next chapter while teaching the capacitance. I will tell you about the dielectric constants and dielectric medium. So in this case, my epsilon naught, the permittivity of the medium with respect to the permittivity of the air. If I take the ratio of these two, I am getting my relative permittivity. So if I write my permittivity of the medium, epsilon equals to epsilon naught into epsilon r. So this is very important result. While solving the problem, they will provide only epsilon r. They will not provide the value of medium, the permittivity of the medium. They provide only the permittivity of the relative permittivity of the medium. So this sometimes you can simply say my K equals to epsilon by epsilon naught, then my epsilon equals to epsilon naught times K. So this is very important concept while solving the problems in the board exam point of view as well as the competitive exam point of view when you are going for a JEE or NEET, whatever it is. So this concept is, this comparison between two mediums is very important. So in the next class I will teach you the vector forms of Coulomb's law and then the superposition of forces. So for more contents, subscribe our channel and share with your friends to get the more updates. Thanks for watching. If you have any feedback, just write in the comment section. We will try to improve from the next videos. Thank you.